Is Laura Matera, and I am going to be doing some math lessons with you. Today, we are going to look at place value related to addition. And we're going to start by looking at some first grade level addition and then move into some second grade level addition. So previously, we looked at how students start with a concrete understanding of numbers. So for instance, right here, I have 8 cubes stuck together. And the kids should understand that they have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 cubes. And we can see that they should start looking at a place value chart, and they should understand that different places have different values. So right now we're just looking at ones digits, and then we have the tens and the hundreds. So if the student has 8 ones, they might then add 5 more ones. And I'll keep these as a stick so you can see. And the students should understand that that means they have to put them all together. 8 plus 5. And if we remember last time, they might take 2 of these over here to turn the 8 into a 10. 3 more makes 13. Now, since we're looking at the place value chart, this is where we want them to understand that when we make a 10, the 10 moves to a new place. So when they are still in this concrete phase, these 3 ones will stay apart as individual ones, and they'll see that the rest of them became a 10. So again, with 8 plus 5, they see that they made a 10 with 3 ones left over. And here is the 10, and this 110 would now move into the tens column. So we see that we have 110 and 3 ones, which is 13. Another example would be 9 plus 2. So again, we'll have the 9 ones out here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we'll add 2 more ones. So since they're adding them, we're just going to put them in 2 separate groups, 9 plus 2. And so once again, the students can see that they have 9, 10, 11, or they can see that that means that's more than 10. So they can put these ones together to create a 10. So I see that we have 9, 4, 5, 6, 7, 8, 9. One more of these makes a 10. And so that means we have 1 in the tens place. And then we have this 1 left over. So our sum is 11. 110 plus 1, 1. Eventually, after they leave this concrete stage, the hope is that they can see it a little more abstract, but still with hands-on materials. And that's where they see that this is also a 10. You can't actually take these pieces apart, but we can see that it looks like it's 10 ones all put together. And then these would be our ones. And so here we might do the same thing, and we'll say they have 7, 1, 2, 3, 4, 5, 6, 7, and let's say they will add 6. We'll have 1, 2, 3, 4, 5, 6. So we have 7 ones and then 6 more ones. As these numbers get bigger, it's good to try to organize them a little more. But 7 ones plus 6 ones. Here, they might count them all, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But eventually we want them to see again that they're making a 10. So they can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in this time, we'll put these ones away and exchange them with a 10. Those 10 ones will turn into a 10, which moves here. And so once again, we have 110 and 3 ones. And that's where they would continue with addition. So now, looking at the second grade level, they would start looking at multi-digit numbers. So for instance, we might have 31. And here they should understand that these 3 objects are each a 10. So even though I only have 3 things here, they're each 10. So we have 10, 20, 30. The 3 in the tens place is actually worth 30. And then we have 1, 1 right here, 31. From there, we can then add a second number. And so, for instance, we might add 25. So I'll put 2 more 10s down here. Again, 10, 20, and then 5 1s over here. And when they're using place value blocks, they don't necessarily need to use the algorithm where they're always starting in the ones place and then going to the tens place and so on. At this point, they can use their basic number sense. They can see that 3 10s and 2 more 10s makes 5 total 10s, which is 50. And they can see that all of these ones together make 6 ones. So our sum is 56. When they need to start following the algorithm, which means starting in the ones place and moving on, is once it gets completely abstract and there are no objects. But the goal of using these tools is that they're thinking about it mentally and not just following rote memorization. So we'll look at one more where it does involve regrouping, and we can see how that would work. So this problem would start with 40. So I have, again, 4 10s. We want them to know that these each are 10s, 10, 20, 30, 40. And then we have 6 1s. 1, 2, 3, 4, 5, 6. So our first number is 46. They should understand this 4 is actually a 40, and this 6 is 6. Then we're going to add 17. So we're going to add 1 10, and we're going to add 7 1s. 1, 2, 3, 4, 5, 6, 7. Now this one does require regrouping. We see as adults that these ones together are going to create a 10. So when they begin looking at the algorithm, they should start here because they know that 1 10 is going to go over here. But with these concrete objects, they can see that, all right, these 4 10s and this 1 10 goes together. I have 5 10s. But then I see I have 6 1s, 7, 8, 9, 10. So I have 50 plus 10 plus 3. And the student can see that these 10 1s turn into a 10, and that means it moves over to the tens place. And so our sum is 63. And of course, when they get to the point where they're using the algorithm, just go back what it originally was. They can see that, okay, we have our 6 1s and our 7 1s. We have these, we're going to turn them into a 10, and we have 3 1s left over. And the 10 goes into the tens place. And so again, once again, we see we have 6 10s and 3 1s, and so the sum is 63. Next time, we will look at place value on these larger numbers with subtraction. Thanks for checking in. Bye.